Thanks very much. It's a great honour to be here to speak in front of you all today. I think I was approached by Ross because I think I'm the youngest person you know. Is that correct? And surely I would know something about artificial intelligence. I don't pretend to know everything about it, but I do have a bit of a background in some stuff that's related to it. So I'll hopefully give you that impression over the next 45 minutes or so. So I came up with this title about, I don't know, it was months ago, wasn't it, Ross? Artificial Intelligence for Society and Science. Why should you care as a question? And then I realised it's actually why you should care. Okay, like it's infiltrating all our lives. It's actually been around for decades, getting to know it, not being afraid of it, experimenting with it, but also being wary of it is a really important aspect of any new technology, that human endeavours have created over over the last 10, 20, 100,000 years. And I must acknowledge that AI was used in the creation of this presentation in terms of helping me to review literature and provide summaries of articles, to coalesce some ideas, and also to structure the presentation. In fact, this presentation was given to a number of PhD students and staff here at Codes about a month ago, and I've built upon that kind of original, how do you use artificial intelligence? How do you use it? What do we need to be careful of? So it's a bit of a mix mash of this, and at the end, or close to the end, hopefully we can give a live demonstration, what could go wrong. And I'm also keen to sort of have an interactive session where, do you use artificial intelligence? Have you thought about using it? What kind of scenarios or ethical considerations do you need to take in this space? So why should you listen to me? I know a little bit about a lot of things, okay? I trained as a geophysicist and like a spatial analyst, a spatial scientist here at UTas about 15 years ago now. And I know a bit about geology, I know a little bit about data science, I know a little bit about computers, I know a little bit about geochemistry, I know a little bit about a lot of things, which can get me into trouble sometimes. The geologists think I don't know anything about geology, which may not be correct, and the computer scientists definitely think I'm not as smart as them. But I'm able to kind of bridge those fields. Okay, I'm a scientist, and in the research that I do, I have a broad variety of things that I'm involved in. About 10 years ago, oh my goodness, 10 years ago, I finished my PhD, which was titled Machine Learning for Geological Mapping, Algorithms and Applications, and I kind of combined geophysical information, remote sensing data, geological maps that have been interpreted, and then tried to assess, could these, machine learning tools, could they replicate these maps? Could they indicate where these maps may need to be double-checked? I developed undergraduate and postgraduate courses that introduce geoscientists to data analytics and machine learning, so I have a bit of a foundational background in that. And I'm also leader of the Codes Program 6, which is Geophysics and Computational Geosciences, so I need to kind of be across a number of these different fields. So hopefully that kind of convinces you to trust me a little bit in the next few minutes. So when I say artificial intelligence, what do you think? Do you think that, it's a force for good out there? Or maybe you think, oh my God, it's going to take all of our jobs, right? Accountants and lawyers, they're all fretting about losing their jobs. Or maybe you think, hey, it's going to help us in manufacturing and it's going to revolutionize our way of life and help us achieve net zero carbon electricity systems and fuel systems. Or potentially it hallucinates and it can't tell the difference between a 6-year-old, a doctor, and whatever. Like maybe we can't trust them. But then again, you might think, well, it'll be good for cleaning up after wars and conflicts, removing landmines. They're serious problems where, for generations people are affected by these things. Or potentially the robot killer drones are going to come for us and shoot us all away because there's these automated drones in the sky that are targeting people and infrastructure, and they're just machines. They're just robots. But what about in education? Surely, the stress that our teachers are under in our education system, surely AI is going to help solve, that crisis in there and increase their productivity, allow them to, mark and assess, essays and reports in an automated fashion. Or potentially every student's going to cheat. They're going to use ChatGPT and they're going to write their essays and they're going to, subvert the system, plagiarize, and have issues with academic integrity. All these things could be real. But then again, the climate's changing. You've just seen the weather this weekend. There's more to come. Maybe the machines are going to help us predict these forecasts and provide, accurate and up-to-date and timely information about serious weather events that are going to protect infrastructure and people's lives. Or maybe they've just stolen all our intellectual property by training ChatGPT. My papers are out there in the ChatGPT world. They're all being, and there might be sensitive intellectual information that's now in those machines, and they own them. Or we could solve the productivity problem in Australia. We'll just become way more efficient. We'll be able to do lots more things with less money. Or we're going to be surrounded by disinformation and misinformation. Deepfake technology, Donald Trump saving the world, politicians are bad, celebrities are, whatever. We're going to be inundated by lies and misinformation, and we're not going to know what's real. Or it'll transform medicine. We're going to be cured by all of our diseases. We'll have early diagnoses that's going to prevent, reduce the impact and the pressure on our flailing health system. Or my favourite, they're going to make you commit suicide. Okay, this chatbot it's going to convince you that you're better off dead because you're a blight on the earth. Okay, this poor Belgian guy, he was a family man, a father. He was in medical research. He was depressed, and he got talking to a chatbot, and apparently it convinced him to kill himself. So where do you sit? All right, are you on this side? It's going to solve all our problems. Or are you on this side? Run for the hills. Get in your bunker. Where do you sit? There's a lot of hype out there, and hopefully by the end of this presentation, you'll have a better idea about that hype and be able to kind of navigate that. And I don't have all the answers, all right? I know a little bit about this stuff, and I'm still kind of navigating this space. But be cautious, be optimistic, and we'll see where we go. So, a little bit of a background. There's an obligatory learning cartoon there. I'm going to touch on an introduction to AI and its kind of history, where it's come from over the last 60 or 70 years. I'll review some of the kind of basic methods in AI, talk a bit about AI in society and AI in science to adhere to the title of my presentation. And then I'll ask you, is it a force for good or evil? Probably somewhere in the middle. It is designed by humans, so it will amplify our strengths and weaknesses. And then an interactive session. What could go wrong? And I like to think of these as tools, all right? There are understandoscopes. There's a seething mass of chaos out there that our world is. It's complicated. We can't possibly digest and understand all of it. But these tools are designed to take all of that information in, filter it, and provide some kind of perspective to it. So an understandoscope. So what's the challenge? You might have heard of something called big data. All right, it's things we can do with large amounts of data that we cannot do with small amounts to extract new insight or create new forms of value. Big data is financial transaction. It's internet communications. It's Facebook clicks and likes. It's transport systems. It's air traffic control. It's satellite data. It's all of those things. There's just so much of it. Impossible for a human to digest all of it at once. Okay, and it's just getting more voluminous. It's coming in more rapidly. We need to do something about that if we're going to make sense of it. The other aspect of this is data fusion. Okay, we're integrating all these multiple bits of data together. Some of them don't fit, images or voice or text. They don't fit nicely. And data fusion is a way to kind of enhance the signals within those data that you're interested in. And the example here is in one dimension, those two groups are not visible, okay? It just looks like a normal distribution, either in one of those dimensions. But when you combine more than one dimension, then you start to see the patterns within these data. And these tools are combining hundreds, thousands, potentially millions of different dimensions or features in order to try and understand these patterns in the data sets. So, artificial intelligence is it's a term, some people don't like it, but they're computer systems that perform tasks normally requiring human intelligence. So visual perception, identifying cats in photographs, okay, or your face. Speech recognition, so your voice to text in your computer, that's artificial intelligence. Decision making, so in terms of activating severe weather warnings, so they'll bring in all of the weather information, the satellite data and the on-ground observations and say, hold on a minute, this weekend is going to be rough, get ready. And translation between languages, which is amazing. There's that thing where you can take a photograph of on your Google phone and it'll translate it in real time. That's artificial intelligence. Modern AI is typically built using these things called machine learning algorithms. And basically they're just bean counters, okay? They find complex patterns in the data, use them to form rules, and then generate predictions. Oh, I've seen this example of a cat before. Oh, here's a cat in that photograph. And all of this is wrapped in this thing called data science, okay? You need computers, you need servers, you need software technicians and hardware people. There's a whole infrastructure that sits behind these artificial intelligence tools. And that must not be forgotten. So, where did AI come from? A room full of old white guys. Yep. So there's already a kind of a bias creeping in here. Okay. So in researching for this talk, I found out that the Dartmouth conference in the 1950s, 50 participants from computer science, maths, and psychology aimed to make machines use language, form abstractions, and concepts, solve the problems that humans usually solve, and they coined the term artificial intelligence over that conference. And they thought they could make machines intelligent in one summer. How about that? How are they going? Yeah? What do you reckon? So overinflated expectations, that's okay, but that was a starting point. I bet there weren't many women in the room, and definitely not people of colour. So the early beginnings. So in the 50s, after this Dartmouth conference, they kind of started to formulate, well, how are we going to solve this problem? And they came up with the very basic form of machine learning algorithm called a perceptron. Okay, it emulates a biological neuron. There's inputs at one end and there's an output at the other. Okay, makes a decision. It's a binary classifier. It's yes or no, black or white, 1 or 0, true or false. And it's the simplest form of neural network. And we'll talk a little bit about these neural networks a bit later. And it was developed in the late 50s. And it works a little bit like this. We have our inputs, and it could be multiple variables or features. And we're going to ask the question, is it nighttime? Okay. Well, one of the inputs is the amount of light outside. Okay. Is it dark? Well, it's nighttime. Well, maybe not in a solar eclipse. So then you ask yourself, well, is it time? What time of day is it? Is it 12 o'clock midnight or is it midday? And then you might have some other inputs in there, and the question is, are there birds in the sky, or how many birds are in the sky? And with those individual inputs, this perceptron can give you an answer. Yes, it's nighttime outside because it's dark, it's midnight, and there's no birds. Nighttime. Okay. And so that's at its basic principle. These are how they work. They're basically just kind of if-else sort of functions. Also around that time, they came up with this thing called the Turing test, or well, Alan Turing came up with it. And basically, they want to assess a machine's ability to exhibit intelligent behaviour. And there's a game that they play. So if you cannot tell the difference between the output of a machine and that of a human, that machine has passed the Turing test. And as you'll see later in this talk, we've kind of got to that point. Okay, with some of the Gen AI or large language model outputs, some of it is indistinguishable from a human interaction. Where does that take us? Well, then in the 70s, there was the AI winter. I love a Gartner hype cycle graph, one of my favourite graphs in the whole wide world. You start off with this technology and everybody's excited, yeah, it's going to change the world. And then you have all of these expectations flying high. Everybody's paying, buying shares in computer companies and servers and stuff. And then they realize that, oh, geez, we actually overpromised and under-delivered. We've created a lot of criticism and disappointment. Projects have failed. Oh, dear. We're now in the trough of disillusionment. Okay, it's not going to work. It's terrible stuff. And then the technology evolves. People become a little bit less expectant about what it can do. And then we enter the slope of enlightenment, and then we hit this plateau. Where are we now in artificial intelligence on the Gartner hype cycle? Who knows? But this AI winter in this little bit here in the late 20th century, funding cuts, reduced interest, stagnation of development. Then there was a resurgence, okay? And it came about because of a couple of things. Increased computing power. Microchips were able to count faster, all right? Big data came in. We're starting to gather more digital information. Advancements in machine learning. So since the 2000s, there were a suite of different algorithms coming through. The artificial neural networks, deep learning systems later on, and the hardware and network connectivity to bring all of that information together and make it available in real time. And parallel computing to speed things up. So all of these key advancements, then there was this resurgence in AI over the past kind of 20 to 25 years. So we're here now, okay? 2024, and let's start thinking about the methods. There's two general classes, or there's two basic classes. There's narrow AI, which is everywhere, and there's general AI, which is Skynet and the Terminator, and it's going to kill us, apparently. So narrow AI is weak. It performs a specific task, voice recognition. It doesn't find cats in photographs. It recognizes your voice and converts it to text. That's all it does. Self-driving vehicles. They don't operate, metallurgical refineries and processes. They drive cars. That's all they do. Okay. They operate within a limited set of constraints. They cannot perform other functions, and it is the current state of AI. It's all narrow. Okay. Artificial general intelligence is like, for computer scientists. If they can create a sentient machine that can perform any task, understand, learn, adapt, implement across all domains, a bit like HAL in the Space Odyssey 2001, and it's still theoretical for the moment. Okay, we're nowhere near that yet. But the rapid change that we've seen recently in the last few years, who knows? It might just be around the corner. And imagine having something like that in Elon Musk's pocket. Hey. So, what are some of the basic methods? There's kind of three different flavors in this sort of machine learning world. There's supervised learning, and that's essentially classification and regression. So linear regression is machine learning, all right? Basic, simple stuff, but it's machine learning. Unsupervised learning is essentially trying to find structure within data. And then there's this thing called reinforcement learning. And basically the computer tests itself against an environment. It goes, oh, if I turn left here and I smash into a wall, oh, watch out for the wall. I won't do that again. Let's talk about these in a little more detail. So supervised learning is the one that you probably most encounter, where you have labeled input. You've got some kind of reference information, okay? It might be images of cats, okay? Images of dogs. Is it a cat or is it a dog? Well, it's been trained on cat images and dog images, all right? This training data is crucial, absolutely fundamental to how these systems work. It needs to be complete and comprehensive. You must have all the different flavors of cat and all the different flavors of dog for it to be working on anything that it sees in the future. It's got to be consistent. You can't have, so in geological databases, the amount of different names granite gets given, spelling mistakes or abbreviations, it's inconsistent. You want it all to be the same name. And it needs to be correct. You can't have a cat that's labeled as a dog or a weasel or a frog or whatever, okay? They don't like that. Some of those systems are less influenced or sensitive to noise within the data sets, but the amount of time and money spent curating these input training data sets is phenomenal. Apparently so when Enron went cactus in the 80s or 90s, and there was all that problem with them rigging the energy system and making money off it. All of the court documents had all of the Enron corporate emails in it. Okay, there was like hundreds of thousands of emails. And that was used as a training data set because it was rich text. It was people talking to each other, people, talking about what they're going to do on the weekend, or trying to avoid the feds when they were knocking on their door. And so that publicly available data set was used to train some of the first ChatGPT style things. It's absolutely crucial. And so with supervised learning, learning is initiated using, the observations. They train, they identify these patterns, they build a series of kind of logical decisions, and it links the observations to data using some kind of function. There's usually a loss function in there. If you get it wrong, then you get penalized. Okay, if you get it right, you get rewarded. And these trained models are then used to make predictions of data it hasn't seen yet. Okay, and that's essentially how supervised learning works. For unsupervised learning, there's no prior knowledge of the structure within the data. Okay, that's part of the objective, is to see if there is structure within it. Are there natural groups or clusters? It's also used for dimensionality reduction. I was talking about all of these, big data and all of these different inputs. Well, some of them aren't useful for the task. Okay, a lot of them are probably just noise. So these dimensionality reduction techniques start stripping out the irrelevant information. Okay, and so it just concentrates on the key signals in those data sets. And one of the aspects of unsupervised learning that is tricky is that you need to then interpret the structure of that data. You've got to have some other information to compare it with. Okay, and then you can start to develop interpretations and build knowledge about the structure of the data. In terms of reinforcement learning, you get this thing called an agent. Okay, it's just a computer. It makes decisions by interacting with its environment, and self-driving cars are trained this way. It receives rewards or penalties based on actions. Oh no, I ran that person over. That's a penalty. I won't do that again. And it uses trial and error. It maximizes the rewards over time, and the decisions depend on its current state. Okay, it's building knowledge of its environment over time and learning to make decisions. And it also explores new actions. Okay, it can't be set in stone in its actions. It needs to explore different opportunities, and if it gets a reward, well, okay, I'll continue down that path. If it gets a penalty, then I'll change my behavior. And so this reinforcement learning, having these different functions and agents, is actually a precursor to many of the different systems that we have at the moment, where they're pitted against each other. There's these kind of adversarial networks, they call them, and they're in a competition within the algorithm to make the best decisions. Then we get into something called deep learning, and essentially this is just a term that encompasses many artificial neural networks. Remember the perceptron that I talked about earlier? A simple kind of fundamental neural network? Well, these deep learning systems have gazillions of them, all right? They're all tasked with, observing the data space in a particular way. They're trained on really big data sets, okay? And there's many different flavors, architectures, and tasks. One of the things is that these architectures are unique to that problem, okay? Face detection, all right, there's an architecture for a deep learning system that just recognizes faces, okay? And that's what it does. And it's used in healthcare, visual recognition, text analytics, cybersecurity, economic fraud, all kinds of things. These systems are being deployed everywhere. Then we get into something called natural language processing. Okay, it's basically machines looking at text and deciphering their meaning or understanding. So particularly human language. Text analysis, information extraction, so your spell check and your grammar check, this is a natural language processing system. okay? And these are the precursors to the ChatGPTs, all right? These where they've designed ways of bringing in text and trying to make sense of it, okay? Which words often appear together or in sequence. And so then we get to generative AI, it's called. So this is your ChatGPT. They're essentially something called large language models. And they learn from existing data. They're supervised systems. And they generate these things called artifacts. And they can be used for making images, videos, music, speech, text, software code, product designs. You would have heard of ChatGPT. The image one is DALL-E. Ada is a healthcare one. So they're out there. They've been around for a couple of years now. And lots of people are using them. And that's good. And potentially not so good. And they're essentially probability machines. So if you put in a prompt which says, tell me something about famous Australian cricketers, okay? It's going to look at that prompt, search through all of the information that's hoovered off the internet, and then give and identify the highest probability of an answer about, Australian cricketers. Okay, Alan Border's one of them. He turns up in a lot of stuff. So Alan Border, and then we'll find information about age, when he played cricket, that kind of thing. They can be inaccurate or biased. Now we'll talk a little bit about biased systems in a bit, but they're trained on the data out there. Okay, there was a great, it wasn't great. There was a chatbot that Microsoft released about, was it 10 years ago or something like that? I forgot what it was called. And they released it to great fanfare. Hey, interact with this chatbot. It's going to be so cool. It'll talk to you. And within 8 hours or something, they pulled it from the internet because people have been training it to be racist and fascist, and it enhanced a particular part of the human condition. Okay, and they killed it because it learned to be horrible very quickly. So we can bias these systems, and there is a lot of bias embedded in them. And this thing about human validation is essential. However, one of the challenges is, how do we know what decisions they're making and why they've made that decision? These things are black boxes, all right? They are so complex, even the developers don't know how it gets the answer. Okay, it's just the right one. Oh, great, cool. Well, how do we interrogate that? And that's something that is a challenge moving forward. So let's have a look at current capabilities. So 100% is human baseline, average Joe blogs or Jane blogs or Genevieve. And we can see over the last 10 years-ish or so, definitely image classification, they do better than humans. Basic level reading comprehension, visual reasoning coming in there, and they're catching up with competition level maths, language understanding, common sense reasoning. So, we're basically in this space beyond the Turing test, where these machines are doing better than most humans in these situations, okay? Scary, yeah. So let's have a look at AI in society. Well, it's already here, okay? Machine learning and expert systems have been around for decades. They play games, they detect credit card fraud, your email filter's one of them. There's heaps of examples. Deep learning systems and natural language processing systems are ingrained in our online lives. Grammar and spell check, language translations, social media feeds, they're tracking everything you do on the internet. Image classification and facial recognition are just some of the examples of these systems in our lives, ingrained in our lives already. And here's a bit of a case study. 2016, Google trained a machine to play Go. Okay, Go is an ancient Chinese board game with 10 to the 170 possible configurations. Apparently that's more moves than the number of atoms in the known universe. Pretty complex game. And they designed AlphaGo, and it's integrated neural networks. Remember how I was talking about that pitting themselves against each other? There's two sort of tiers of networks in there. One of them selects the next move to play. Well, the other one kind of predicts, well, if I make that move, am I going to win or not? Okay. And so it beat the Go world champion in 2016. I think he was so mortified that he decided never to play Go again. And so, machines beat the world champion. But in 2023, an amateur ranked player beat AlphaGo, all right? But it was very specific in how they addressed being this machine. They exploited a flaw in the AlphaGo gameplay that was identified by another machine. Basically, the other machine played 1 million games against one of the Go machines, and it identified a flaw in the gameplay and then taught the human how to play the game. So it's very, very specific. These things are not infallible, all right? At the moment, they're designed to do one thing, and if they haven't experienced the full breadth of possible opportunities, then they're not going to know how to beat the human. Humans, we're getting it back. All right. Go, get away, computer. We're better than you. So here's a list of some of the new developments. There's also a graph here about investment in artificial intelligence. You can see that in 2021, there was a big boom, with the whole OpenAI stuff going on in the background with Microsoft and who knows who else, Musk and his mates. And it's used in finance. Fraud detection, gives you personalized financial advice if you're into that thing. National security, they're surveilling everybody. They're making sure that the hackers can't get in, or they're trying to hack other people. Healthcare, personalized treatment plans. If you're comfortable with your personal medical information being read by a machine and combined with everybody else's, then you might get early diagnoses about something. Criminal justice. It's a little bit like the Minority Report thing, predict potential criminal activity. Transportation, optimize traffic flow, enhance safety, watch out for self-driving cars, and smart cities, predict energy demands. Let's talk about energy systems. Pretty important thing going on at the moment. We're trying to wean ourselves off fossil fuels, emerge in the brave new world of a green and renewable, sustainable energy system. And we need computers to do that, all right? Expected benefits, optimize the power grid, reduce wastage, ensure reliable supply, predict supply and demand, and integrate the renewables. Solar power is only generating power when the sun's shining, and wind only does it when it's windy. How do we, reconfigure our electricity grid system so that it can handle these different systems and scenarios? Manage electricity flows between generators, predict equipment failures, plan maintenance, that kind of thing. There's a whole raft of things that these tools could help us with. However, there are some impacts. The amount of electricity that these systems use is phenomenal, okay? And they're mostly run by coal-fired power stations, okay? Just because this graph at the bottom here, that's basically global energy consumption and production. By which type? Coal's at the bottom there. Renewables, solar and wind are at the top. Sure, we're building new solar arrays and wind farms, but we're not keeping pace with the increasing energy demand, okay? And I'm not saying that it's only ChatGPT and artificial intelligence that's the root cause here, but they are contributing to this. So they're going to save us from climate change and cause it at the same time? I don't know. So they're also, the big servers, they need enormous amounts of water to cool them. So there's natural resources that are needed by, living things that these systems are consuming. And that increased strain on the grids potentially leads to instability and other problems. So it's not, sure, it can potentially solve some of the problems that we are facing with this transition to a low carbon emissions energy system, but it may also be exacerbating and increasing it. So we need to be careful. But let's get to AI and science. Well, what do scientists think? Okay, Nature survey, they looked at 1,600 researchers. They asked them a few questions to look at some of the kind of responses. AI use is definitely becoming more common in research. The scientists expect it to become central to their work in the next decade or so. The reason for that is faster data analysis, saving time and money, increased productivity, that kind of stuff. Some of the applications to summarize and write research papers, brainstorm ideas, write code. I use ChatGPT type stuff to write code. I'm not, I know how code works, but I'm not fluent in Python syntax. So I'm saying, okay, in Python, give me some code to do this. Spits it out. 9 times out of 10, it's right. And it's changed. It's a game changer for me in terms of being able to code in different computer programming languages. There's new protein structures being developed, improved weather forecasts, medical diagnosis. We've talked about this, and we can see this graph here. We've got time or year across the bottom, and these are the proportion of articles that mention AI in their title or abstracts. As you can see, computer science is the leader there, but since 2015, everything's jumped. Okay, we've gone from 10 to 5, 3% down here. A huge increase in the use of these systems in scientific research, which is great. But there are concerns. There's concern that we're relying on these tools to do pattern recognition without understanding process. Okay, we are potentially risking bias and discrimination within the data sets. These inherited biases within the systems. And there's risk of fraud, okay, and issues with scientific reproducibility. So let's talk about some of the new developments. So, in my sort of trawling of the internet to summarize this information, new developments in science is accelerated literature and data analysis, identify research gaps, formulate hypotheses, process and analyze large amounts of data, identify patterns, gain insights into data sets that humans just couldn't possibly manage by themselves. New research methodologies, so modeling and simulation, improved accuracy, collaboration. We can, potentially fluently communicate with people all over the world in different disciplines and different backgrounds by providing common tools and a framework for data analysis. And there's a number of ideas out there about, being involved in the future development of these tools, focusing on improving the AI models, reducing some of the bias and discrimination in there, developing guidelines for their use. So we're just starting to catch up by saying, the UTas just recently released its updated, AI and research guidelines and policy, and it's a huge document. They're trying to cover all of their bases. And so all the students and staff at the university now have this guiding framework in order to ethically and responsibly use AI in the university for their work. So there's all sorts of opportunities out there. But what about in scientific publishing? One of the challenges that we're facing is it can be used to fabricate data. It can be used to write papers. Okay, there was a couple of months ago now, someone noticed that in the introduction to a paper that had recently been published, got through the peer review process, there was, sure, I can help you write an introduction for your scientific paper. And they got ChatGPT to write them their paper, and they forgot to remove the bit where it's being nice to you. Okay? That's an obvious bit of fraud in there, okay? But it could be helpful for people who don't have English as a first language. Like, we've got dozens of PhD students from every continent on the planet except Antarctica, and they're using Grammarly and those AI tools to help them refine their grammar and their written language structure. So it's really useful. And it appears to be increasing in writing papers. So these graphs here, sorry, they're a little bit small. But essentially, we've got time along the x-axis and the number of occurrences of particular words. In this side here is control words, so you've got after, conclusion, before, blah, 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 kind of normal words that scientists use in their scientific literature. And on the other graph here, we've got these so-called AI-associated adjectives. So these are words that are, things like innovative, fresh, notable, intricate, they're meticulous, like they're real English words, but people don't use them that often. And AI, ChatGPT type stuff seems to use them quite a bit. So they're tracking the increase in the use of these words over the last few years. And they're seeing that in all of the scientific literature that they trawl through that some of these words have had a 200% increase, almost 300% increase over the last 2 years. Okay, so there is likely, and it's really hard to track and keep ahead of, there's likely a lot of AI-assisted scientific publishing going on. And it's, how do you tell? Because they beat the Turing test, okay? Can't tell. So be careful out there. So it raises questions about plagiarism, authenticity of published research. AI is also being used to combat this creeping of potential fraud in the scientific publishing by detecting plagiarism, looking at statistical manipulation. There's image fraud going on out there. There's a really good website called Retraction Watch, if you're interested in these things, and it gives you a summary of, you know, how many papers have been retracted by these prestigious journals from these dodgy scientists who, you know, are playing the game, publish or perish. Unfortunately, there are accounts of researchers being wrongly accused of using generative AI, large language models, in the peer review process. If you just do a quick search out there, there's some people out there with ideas on how to prevent that from happening. So basically keeping really meticulous, is that word? Meticulous records of your research, so that when somebody says, oh, this looks like it's written by ChatGPT, you can say, well, actually, here is version-controlled drafts of my whole scientific process. So, but it requires a lot of work, you know. You're going to get the ChatGPT to do it for you? Chasing our tails. So let's revisit the Turing test. Remember, it's the ability of a machine to exhibit intelligent behaviour indistinguishable from a human. And apparently ChatGPT surpassed that, passes tough exams, write convincing human essays, and chat fluently with people, and even get them to commit suicide, apparently. It still struggles with simple visual logic puzzles. So these puzzles here, there's a concept arc test. Humans can do it pretty easily, but apparently ChatGPT can't. So they're still failing in kind of abstract thinking, visual logic puzzles, and reasoning challenges, because they're innately human kind of things, visual processing and stuff like that. And there's ongoing debate about large language models, whether they're really intelligent or they're just really good at reading fast and recalling all of that written information. So there's talk out there about new benchmarks for assessing the performance of large language models, but also to keep track of them. You know, can we tell if it's a human or a machine talking to us? So let's kind of recap. Benefits of AI: efficiency and productivity, automate routine tasks, free up time for complex tasks, decision makings, identify patterns, sift through those really big data sets, informed decision making, help us make decisions more effectively, accurately and rapidly. And it personalizes your user experience, you know, your Netflix algorithm or whatever. It remembers how much of a show you watched and all the genres that you've got, and it'll spit out, you know, oh, you should watch this next. Tailored to your individual self based on your behavior and preferences. Hey, who wouldn't want that, you know? I like, you know, apparently I'm really interested in stories about climate change and, you know, changes to the energy system, partly because I teach some of that stuff in my work. But what about the concerns? Okay, there's data privacy and security concerns, copyright issues. So there are artists that are jumping up and down because DALL-E hoovered up their artwork off the internet and then started basically reproducing it and passing it off as a machine-generated thing. But these struggling artists who, you know, they live on the sweat of an oily rag, their work has now been taken up by these machines. Okay, does that mean that now people aren't going to appreciate and buy their artwork because they can just, you know, sit down and in 5 minutes make it themselves? Sensitive information, so medical records, you know, you don't want medical insurance and life insurance companies getting hold of all your medical records. They probably already do, sorry about that, because they'll, you know, they know how long you're going to live. based on your behaviours, preferences, your demographics, etc. Mass surveillance, they're watching us all. Data breaches. There's issues with deep fakes, so there's a really good Keeping It Real, How to Spot a Deep Fake by CSIRO. It's just a quick website to give you sort of tips and tricks on, hey, how can you tell if that's made up or not? One of the other aspects of the concerns is its dependence on data. It has enormous data requirements to train these tools. And there's issues about quality and representativeness across all demographics. Other concerns, ethical considerations, embedded bias. So this is an example of face recognition technology. And basically, if you're a white male, your face gets recognized with way more accuracy than if you're a black female, okay? Because these tools were trained on white male faces, okay? There's biases embedded in them. And this is implications for, there's stories out there of people being wrongly arrested because they've been misidentified in facial recognition systems because they have ethnic backgrounds and different face structure to Westerners, okay? And it's a real problem, and people are trying to tackle this. Also, over-reliance in decision-making. Do we become too dependent on the machine telling us what to do? What happens when the power goes out? What are we going to do? Panic. Energy consumption, we talked about that, and equitable access. At the moment, OpenAI is saying, yeah, everybody can use it. Are they going to monetize it? Absolutely. They're going to push. They're going to push the button. They're going to push the button, and then they're going to charge you for it. Get you all addicted on it, charge you through the nose. What's going to happen then? Then will be the haves and the have-nots, the widening gap between the 1%ers with 90% of the wealth and the rest of us down here. It's just going to widen that gap. Trust me, it's going to happen. Somebody wants to make money out of it. And lack of common sense, inability to understand context, inappropriate behaviour. If it encounters something it hasn't seen before, it panics. What does it do? So, is there a force for good or evil? Are you in this camp, the utopia camp? Economic democratisation, new job creation, sustainable development is going to solve climate change problems, and abolition of necessary work. Has anyone seen the WALL-E movie? Very good movie. They end up in space being doted upon by the machines. We're not going to have to work ever again. Hooray! Or are you in this camp, the doomsday camp? Oh, they're black boxes, misinformation, disinformation, going to take our jobs. Nothing's going to be private anymore. And it's just going to turn into grey goo, okay? Everything's going to become the same. And I actually have this concern about AI stuff. Like, I'm sure it'll get better, but it's not bad, but it's not good. It's sort of in the middle. It's average. That's what they're designed to do. So if everything ends up being created by average machines, does that mean that everything becomes dull and grey and there's no kind of spark or creativity anymore because it's all just made by machines? Who knows? I'm a little bit jaded by the whole thing. So what's your experience? Have you used it? Do you use it to, improve efficiency and productivity? Do you think about the ethical considerations of using it? The power consumption and the bias and people's data being taken when you use it. Do you need training and support in order to move ahead in this space and to use it effectively? So these are some of the things that this stuff's here to stay. It's not going away. It's like the automobile and sliced bread. It's here. So we need to start being involved in the changes that are going on. Otherwise, we're not going to be able to have a say in how this moves forward. So what could go wrong? We'll do a live example. So I'm going to use this thing called. I really don't like the Edge browser, but I have to use it because the university states that I have to use this system. It's a closed system. Okay, because in ChatGPT, whatever you put into it, it goes into its training data set. Okay, if you put in intellectual property information or intellectual property sensitive information, ChatGPT's got it, okay? So this is a closed system. It doesn't remember stuff, they say. So let's have a look. What could go wrong? Right, I've got my prompts ready to go here. So in this space, it's just, you open your Edge browser, and up in the top there's the Copilot bit, and you just type in your prompt, okay? You become a prompt engineer. I need to make a presentation slide about the impacts and benefits of AI on education, provide 3 to 4 dot points on this topic with links to academic research. Away we go. And yeah, sure, no worries, friend. Personalised learning, efficient administration tasks, enhanced assessment and feedback, support for teachers. Hey, it all sounds really good. But hold on a minute, probably didn't state exactly what I was after. What about some of the concerns? Okay, it's only, you have to be really specific with these things. What are some of the concerns of the application of AI in education? Okay, paste that in. Now, basically I'm using this as a bit of a beefed up search engine, which is a very simple way of using these tools. Other ways, you can create content and all sorts of stuff. So, bias and fairness, privacy and data security, dependence and autonomy, equity and access. The thing that's missed though is plagiarism. Okay, what about cheating? So let's be specific. You gotta ask the right questions. What about plagiarism and cheating? We'll get there. So, and then it'll come back and say, oh yeah, that's a big problem. Yeah. Ease of plagiarism, generate text, cheating on assignments, detection challenges. How do you tell if you've cheated or not? We're facing this in assessing undergrads and even postgrads. Okay. One of my colleagues, Rob Scott, put the third year essay exam question into ChatGPT and got pretty good response. You would have given it an 80 or 85%. So how do you tell that you've been cheating on the exam? It's a big problem that we're facing at the moment. There's all sorts of new policies and procedures about the use of AI in generating content. So there you go. I'll do one other. So I use ChatGPT to help me write code. So I've got something in here, in Python, provide code to do, I might import a data set, I want to do a couple of things to it, blah, blah, blah. See what it says. It's a brave new world, I'll tell you it's a brave new world. It takes a little bit longer because it's got to search a bit more. But I'm interested. Have you used these tools? Yeah, how have you used them? Beefed up search engine like me, or for cheating on your exam? Like how have you used these things? And look, it's going to provide me with the code. I'll just copy and paste it. Like I said, 9 times out of 10, it's pretty good. So it's helping me a lot. And I'm getting it to do pretty, very specific things. But you have to be specific. All right. Enough of that. Let's go back here. All right, let's wrap this up because we're running out of time. So, in conclusion, and these are my kind of musings, artificial intelligence, it's just a tool. Like an abacus or a hammer, maybe, I don't know. However, it is designed and created by humans, so it emulates, amplifies our strengths and our weaknesses, okay? These things are made by humans. Soon enough, they'll be made by machines. We're starting to get into that realm, but at the moment, still made by humans. Current and future developments will transform our lives. Use with inspiration and caution, okay? Be careful, but don't be scared. And interpretability is key to understanding and knowledge. How do you interrogate whether or not what it spat out at you is correct or not? Okay, with code it's easy. You copy and paste it in. If it doesn't work, then it was wrong. And you go, oh, this line here didn't work. Oh yeah, sorry, I missed a bit. But really, we're in this kind of brave new world of computer and human interactions. And the question is, well, how are we going to negotiate the space? Be informed, don't believe the hype. Yeah, it's going to take all our jobs. Oh, it's going to create heaps of jobs. Like the media and everything is trying to separate us out there. So really what we want to do is we want to inform ourselves and be kind to each other. So here's my cringeworthy AI stock image. Thoughtful robots. Yeah, thanks very much for your time.
Yes, mate, that was terrific. I've had a bit of experience with ChatGPT, and I like to ask it questions that I know the answer to initially to warm up. And if you know that it's giving you the wrong answer, then you can think about exactly whether it can go a little bit further. But it's interesting that quite often you'll ask it a question, it'll give you an answer, and the answer's not very good. And it misses a point, like you showed with one of those, and it'll come back and apologise.
Yeah, it's very friendly.
And say, oh, I'm sorry, I'm sorry, I can't give you a better answer for that, or I missed that out. It's amazing.
It's definitely polite.
Yes.
Just a moment ago you said don't be scared of this technology.
Yeah.
But we have the world's electric Jesus in Elon Musk saying that AI is a greater risk to our society than nuclear weapons. Your response, please.
Oh, well, we've tried hard not to blow ourselves up with nuclear weapons, so maybe we won't turn everything into grey goo with artificial intelligence. Look, I don't know, humans are a funny bunch. We're we're really good at we're so creative and so inspiring and so amazing, and we are awful as well. And the machines just emulate that. So, yeah.
And he says further that we should stop all AI development.
Well, they're talking about moratoriums for policies and legislation to try and catch up, because kind of the genie's out of the bottle now. Look, I honestly don't know. I don't know what. There's definitely some enormous ethical concerns out there. There are machines out there trying to rig elections and change the course of human history, essentially. And can we stop that? I don't know. Probably not. We have to, but it's not every person for themselves either. So, look, I don't have a better answer for you than that.
If I could just ask about not so much the esoteric side, but going back to the more fundamentals of the actual training and supervised training of the machine, and it's given a reward, a carrot or a stick for getting it right or wrong. Yeah. Now, I understand how that works for humans and for rats in mazes. Yeah. How does it work? How do you do it?
Statistics. And so you have some kind of function that gives you error. And it says, my error is 10%. Versus 5%. 5% is way better to have lower error. So essentially, there's just statistics in the background that measure performance and accuracy, and we'll do it in different ways. There'll be different weighting functions and cost functions and stuff like that. But it's essentially numbers that are guiding it. Yep.
When you're using AI in research, are you using AI to do the research, or are you using it to write the report about the research?
Mostly what I've done so far is to help me with writing code, but I've also used it to help me write presentations. So some of the sort of structure and the ideas or the flow of ideas was initially provided by AI, but I've gone through and extensively updated that and put my own flavour in there as well. There's talk of people using it to write kind of, the boring email type thing. Oh, thank you very much for your email. I'm sorry to say that I can't do this for you at the moment, that kind of stuff. There are, like some of the examples in there, some of the things that they're doing is looking for new proteins. And so basically what they'll do is they get the AI system to just generate proteins, gazillions of them, and then test each one and say, well, what would the function be of these proteins? And they're sort of getting it to do that kind of research. Yeah.
One here and then one there.
I read an interesting article a while ago that was about sort of called the flat packing of the human experience. And it was essentially saying that with these large language models and so on, they are probabilistic machines, stochastic parrots, some of us call them.
Uh-huh.
I call them stochastic parrots.
Sure.
Because that's what they are,
Yeah.
fundamentally.
Yeah.
But essentially you think about, for instance, building a kitchen where it's something, you just slap it together, and it's not about
IKEA machines.
Yes, essentially. And
Okay.
so all of that comes into play where you're creating that and you're inputting these sort of systems back into themselves. So essentially it converges to that in the limit effectively. And so that then you have that question about what that means in terms of jobs, in terms of productivity, in terms of economy and so on, because you get this decline in the standard, you get it converging to this particular point. But then you've got incentives with the corporations and so on, where, if it's good enough, where that is good enough, because the cost is, 90% or 95% lower, then that is a real concern, because it means they can get rid of people, they can chop all that out, and it does mean that there's that decline. But then you look at the converse of that, where there's more appreciation for artisanal products and so on, real craftsmanship, real expertise, and so on. So it means you've got that divergence again between what is just sort of mediocrity. Mediocrity because it's 90% cheaper than a human that does, 20 or 30% better. And the extremes where you've got sort of...
And machines don't have to sleep.
Yeah,
they don't have to eat. You're right. Like, that was one of my concerns that I raised, is everything becomes kind of average. But capitalism is, an amazing system that is fundamentally controlled by how much money you can make or lose. And so if that's what we're basing our decisions on, then sure, people are going to lose their jobs because the machine can do it as, just as well.
Well, it mightn't be as good, but it's still significantly cheaper.
But humans are random, you see. So these machines, you will get, structured, routine outputs. It'll never be late. It'll never be sick. You will not be surprised by it. Okay, if it's doing the average job.
Question.
Yep.
Thanks for that, Matt. Just like an anecdote and then a question about how it's being used in the academic setting. But I had some mates that developed a prototype where you could submit a paper and then get the author in real time. It would translate it into language that, say, a university student could read, a 12-year-old could read, a 6-year-old could read, so then you could publish greater outputs. But in terms of embedded bias, is this something you're using in the conversations in academia, how to use it as a tool to co-design with students, knowing that they're going to use it to show there's gaps in this literature based on bias. This is where we need to go to research, those sorts of things. Is there any talk of co-design, or is it just seen as how do we measure academic integrity?
That's an interesting question about co-design, kind of teachers working with the developers to build something that's suitable for them. I don't think that it must be happening in places, and it was definitely one of the kind of, the future of AI in science and education. These are the things that we need to do. I went to just quickly, because they're going to kick me out. I went to an online workshop. So some of the things that they're talking about in terms of the benefits of AI in education is assisting and helping people with neurodiversity challenges, and helping to build content that is easily digestible and helping them with making good records and stuff like that. And so we did a workshop where basically there was a series of prompts in ChatGPT to say, you tell me, you've conducted an experiment, now reflect on your approach and reflect on the results, and what are your understandings and interpretations. And so it was a guided kind of interaction with the experiment and the learning. So there's some pretty amazing stuff coming out of that. And if it can help, if it can help people with different challenges, then it's a force for good.
Everyone, please join me in thanking that great